All right, this video is going to be about corresponding parts of similar polygons. First, we have this warm-up talking about the ratio of the measures of an angle of a triangle is 1 to 6 to 13. We want to know the measure of each angle. So we need to plug back into each one. As we talked about, each one of these numbers is going to be multiplied by the same number to get the actual measurements. This is our variable, our scale factor. So that variable that we don't know, we're going to put as x. So we want to add all of these together to equal 180, but we have to add the x onto it. So we're going to have 1x, which will just be x, plus 6x, plus 13x, all equal to 180 degrees. Pause the video, solve for x. Combine our like terms, we should have 20x equals 80, and then we divide by the 20, and x is going to equal 9. So now what we need to do is we need to go plug back in to find each one. So the 1 as 1x is just going to be 9 degrees. When we take a look at the 6, we need to know this as 6x, so 6 times 9. This one will be 54 degrees. And then 13 would be 13 times x, so 13 times 9. This will be 117 degrees. Then when you go and you add 117 plus 54 plus 9, you'll get 180 degrees. The next section talks about, this little table talks about symbols. The symbol for similar is just a single squiggly line. It's like the little squiggly line that goes over the equal when you have congruent. Similar is just this one little squiggly line. Is proportional to is just going to be a colon. We'll see this in a minute. Kind of like what we have up here, okay? Similarity transformation preserves angle measure, which means the corresponding angles are congruent. So just like with congruent figures, the angles will remain congruent no matter how much bigger or smaller. So your corresponding angles are congruent. Now these sides are not going to be congruent like in congruent figures. Similarity transformation enlarges or reduces the side lengths. Okay, and this is by your scale factor, k. The lowercase k represents scale factor. This means that your side lengths will be proportional. So this is introducing facts about similar figures, and now we'll talk about the corresponding parts. We're going to go ahead and name these corresponding parts. We're going to name the congruent angles, because as we see up here, angles are going to be congruent. That's why we have congruent markings. Your side lengths are going to be proportional, and that's why we have this colon, saying that segment AB is proportional to what? So if we look at the angles are easy because you just look for a common number of congruency marks. So angle C is going to be congruent to angle F. Kind of went out of order here. This is over here. Angle B has 2 congruency marks, and so does angle E. And then angle A with the 3 congruency marks will be congruent to angle D. Now we look at the proportional sides, segment AB, and talked about this with congruent figures as well, to find, even though these two triangles the orientation is the same, the top is at the top, left at the left, right at the right, but in case the figure is reflected or rotated, we need to make sure that we understand exactly how to find these. So segment AB right here is going to be the side that connects the 2 congruency marks to the 3 congruency marks. So over here we find the 2 congruency marks and the 3 congruency marks, and this is going to be the side it is going to correspond with and be proportional to. We did list it as AB, the 3 mark to 2 mark, so we have to name it DE, 3 mark to 2 mark. So this will be proportional to segment DE. Then we look at segment BC over here. We're going from 2 marks to 1 mark. So over here we'll go from 2 marks to 1 mark. Segment EF. So segment BC is proportional to segment EF. And then lastly, our third and remaining side, we're looking at segment CA. Look at the order they went, C to A, 1 arc to 3 arcs. Over here, FD, 1 congruency arc to 3. So segment CA is proportional to segment FD.